All right, in this video, we're going to look at tangents of a circle. So before I get into it, I don't have the definition of tangent here, but just in case you didn't remember what a tangent was, a tangent is a line that's going to come across a circle at only one point. So kind of like just touches the circle and it would keep going. It doesn't actually enter the circle. It just touches it at one spot. Okay, so now we have a tangent of a circle is perpendicular to the radius, drawn at the point of tangency. So that's that point where they touch. That's called the point of tangency. So two tangent segments of a circle originating from the same point are congruent. So if we kind of look at this diagram, I know this is the problem, but we have a tangent is perpendicular to a radius if it's drawn at the point of tangency. So these would be perpendicular because I have a radius here going from the center to the side, and I have this tangent coming down and touching the circle right here at R. And since that's where the radius and the tangent are coming together, they are perpendicular. And then we have two tangents drawn here from the same point, and those would be congruent to each other since they're drawn from the same point here. So from here to the point of tangency, and then from here to another point of tangency would have to be the same distance. So I know I already kind of talked through the problem a little bit there, but let's talk through it with the given information. So we have in the figure below, the segments QR and QS are tangent to the circle. So they're telling us QR and QS are tangent. We could see that already kind of when I was talking through it. I could see that it was just touching right there, but you want to make sure that they tell you that so that you're not guessing at it. We have our center O, and we're given that QS is 9, and that, I'm going to back up a little bit there so I can see it, and that OQ is 10.2. So here we have QR and QS, and so we know they originate from the same point, right? So they're congruent. That was one of the sentences we just read up above. That's one of our properties of a tangent. So they're both originating from Q, so QR and QS are going to be the same length. And since QR or QS is given to us as 9, we can see that here. Well, that means that QR is also going to be 9. So OR and QR are perpendicular. I was talking through that just a second ago, right? We have a tangent and a radius coming together at the point of tangency, so they are perpendicular. So these two will be perpendicular to each other. And that means that triangle OQR, this triangle that's created here, is a right triangle. So now we're going to jump back to a previous theorem that we haven't used for a little while, because whenever we have a right triangle, we can use Pythagorean theorem. Because I want to know what this missing side is, right? I have this 10.2 here for this length. I know this one is 9. I'm just missing the blue, the OR, which is what I want. So I'm going to use Pythagorean theorem, which is a squared plus b squared equals c squared. So remember A and B, those are my legs, and I have those marked in blue and red here. And then the C, that's your hypotenuse, that's your longest side. It's always, you look at where your right angle is and you go across from that. So 10.2 is my C. So now we'll go ahead and we'll fill this in. So we have 9 squared plus b squared, because I just decided that QR was 9, or QR was A, sorry, and that OR was B. And then I have C squared is 10.2. So now we're going to go ahead and square them. So 9 squared is 81. B squared stays B squared for a moment. And then 10.2 squared is 104.04. So now I'm going to subtract 81 from both sides so that I can get B squared by itself. So now I end up with B squared equals 23.03. So I just subtracted. 81 minus 81 cancels on this side, right? So now I'm going to take the square root because I don't want to know what B squared is. I need to take the square root of both sides so that I can find out what just B is. Because the square root of B squared is just B. And then when I do the square root of 23.04, I get 4.8. So that means that OR, instead of just B, I'm relabeling it OR, is 4.8. That doesn't say OR, it's the length OR. So that was problem type 1. Now we're going to look at problem type 2. So we have a second type of problem. So in the figure below, PS and PQ are tangent to the circle, centered at O. So we do have our center and we have our tangents. The segment SQ passes through the center. So we can see SQ passes through the center. So it's kind of a diameter that keeps going a little bit here. Okay. So it comes out of the circle. We actually have another name for that. It's called secant, but we haven't messed with those too much yet. And we're given that PR equals 5.2 and SQ equals 3.9. And they want us to find the length PS. So let's go ahead and label all of our given information here so I can see my tangents. And I'm labeling it only to R here because it's the point of tangency. So PR and PQ are going to be the same length. Okay, not all the way to PS. That's actually what they're asking us to find. So if I know that PR is 5.2, I also know that PQ is 5.2. Okay, because remember, those are both tangents from the same point. So they're both going to be 5.2. They also told us that SQ was 3.9. Okay, so I went ahead and that's labeled in there. And how are PQ and QS related? So they're not necessarily related by being congruent or anything like that, but this is, it's not necessarily the whole thing. We said diameter or radius, but this can also work. So if we think about either just the radius or the diameter, that's going to be perpendicular to the tangent, right? So we know that that's a perpendicular angle here. That's a right angle. So that helps us because now we can see I have a big giant right angle. I'm going to use Pythagorean theorem again to fill in this little piece. So we're going to go through and do our a squared plus b squared equals c squared, but we have a little bit of a funny piece on this one. So now I need to do this whole thing. This whole thing is c. So I have 5.2 plus x. That whole thing is c, not just x, not just 5.2, but the whole thing. So now when I fill this in, I decided that this length was my A and this was my B. Remember, those are just the legs that create that 90 degree. C is always across from the 90. Okay, so now I have 5.2 plus 3.9 squared. And for right now, I'm just saying C squared. I'll come back to this in just a moment. I'm just going to find out what the whole length has to be instead of trying to deal with this piece and square it. Okay, so now I'm going to go 5.2 squared, and I get 2704. 3.9 squared, that's 15.21. So now I'm going to add those two together, and I get 42.25. And 42.25 equals c squared. So I'm going to take the square root of both sides so that I can just know what c is. So c, the whole side, the whole thing, is 6.5. Now, I don't really need to know what this one is, SR. If they had asked me, because I have seen them do that, where they just want to know the little piece, I would just have to take this and subtract the 5.2 to find the little piece. But they actually want the entire thing. They want to know what PS is, right? This little piece doesn't really matter. So just pay attention to, what are they asking you for, and make sure that you complete the entire problem. So that is using tangents of a circle. I hope that helped, and I'll see you on the next video.